Going back from the previous video where we say that the normal line is going to be perpendicular between the prism and the air, or should I say different between two mediums, what I'm trying to actually say is 78 is actually based on the perpendicular line itself. So we're going to put a dotted line right over here to represent the normal, which should be right there. 78 degrees. What we're going to say is try to find the angle right here, because that's 78 degrees from this line. We're trying to find what degree of attack is going towards the normal. Let's try to do simple math. 90 minus 78 should be around 12. This is going to be 12 degrees to the normal. So somehow we are going to have to understand that 12 degrees is the new normal. So we have all the parts for our first Snell problem. So remember, Snell's problem is n of 1 is going to be multiplied by the sine of theta, and that's going to be equal to n of 2 of sine of theta. It's a way to help us clarify and understand what the light does after it changes a medium, and what angle to the normal line, the perpendicular line between the two different mediums, what angle is it going to go off of? So let's see what happens. Into our problem, we said that air is going to have an n index of equal 1. The prism inside of it is going to be equal to 1.62, referred to the problem right over here. So here's the first one. We are going to say air on the top as the left one, and it's being transferred to the prism right over here. So 1, multiply that by the sine of 12 degrees based on the normal, and that's going to be equal to 1.62 based off of the sine of degrees of the normal that we're trying to find. So now we have the problem written all out. Find the sine of 12. And on the crazy calculator, we are going to hit reset, and the sine of 12 should equal 0.279. Times 1 is pretty much the same thing. 0.2079. And that's going to equal 1.62 sine of theta. Just like simple algebra, divide this side by 1.62, but also divide that by 1.62. So on that crazy calculator, divide by 1.62 and get to 0.1283. 0.1283. 0.1283. So now we have to find the sine is going to equal that. But sometimes there are signs where we have to go a little bit further. We have to find the sine of -1 and use an opposite trigonometric function like that, and that's going to equal 0.1283. That's going to determine the angle of refraction into the prism. What's going to happen? Let's find out. So the second -1 sine is going to be equal to 0.1283, and our final answer for that one is 7.37 degrees. So we are going to put 7.37 degrees. That is going to be the amount of degrees that's going to be pointed towards the medium inside the prism. So that is the first one. Not only the light tends to go inside the prism, but we also know that light tends to go into a straight line. But there is one little issue. that prism is going to change the direction when it comes out. So somehow, when it goes straight like here, there's going to be some kind of direction that's going to change. We might say, oh, why can't we just insert 7.37 and do the opposite of what we just did, since now the light is leaving the prism? Well, notice how this is not just any kind of triangle. Yes, it's a right triangle. And sure enough, we can say that the right statement is it's a 30, 60, 90 triangle. This refers to 90 degrees, which means this must be 60 degrees for 180. So this gigantic triangle that the light is going in, this prism is actually a 30, 60, 90 triangle, meaning that we can't assume it's 7.37 degrees. I'm just going to round that to just 7 degrees and just go from there, because it's really kind of hard to just put it as decimals. So, notice how we have 30 degrees way up there, and we have 7 degrees way up there. Some angle that goes way over here. This isn't actually 7, because when that normal goes through that line, it's going to be 90 minus the 7. So 90 minus 7 is going to equal 83. So if you take a look and try to do its complement instead, well, we're going to say that this is going to be 83 right here. I'm going to draw a triangle right here. So right here is 30. This is going to be 83. What number right there is going to be right there? Let's try it on a calculator. 180, subtract that by 83, subtract that by 30, and that should equal 67 degrees. 67 degrees is going to be way over here. They're calculating that angle is 67 degrees and that light goes in a straight line. The crazy thing is, somehow we could say that there's another normal line going across that too, going in this direction. Now, the light has to go outside the prism to complete the problem. If that is 67 degrees right over here, and we can say that the normal is going to be perpendicular to the prism and the air, meaning that it must be 90 degrees. If that is 90 degrees, it could help us, because now we have to say 90 subtract by 67. On that calculator, 90 subtract by 67 is going to be 23. So, the angle of attack, or the incident ray that is trying to get out of the prism, is going to be 23 degrees. And that's going to be right over here. So now, we have the final formula that we're going to solve. Similar to this, we have to do it again. So, N1 sine of theta is going to equal N2 of sine theta again. But in this scenario, we're going to go from the prism back outside to the air. And sure enough, when there is an air, there is the end. So this is the final thing we have to do in this video. The N1 is going to be 1.62. The sine is going to be 23 degrees, because that's what we calculated from that normal of 90 degrees. 90 minus 67 is 23. And that's going to be equal to, air is just 1, the sine of theta. So, the sine of 23, then we have to multiply that by 1.62, 0.6328 equals 1 sine of theta. Divide by 1, divide by 1. And, yep, I'm just going to divide by 1. Yeah, the same thing pretty much. 0.63298 equals the sine of theta. Now we have to do the sine of negative 1 equals 0.63298. Now, if we do the second sine negative 1, 0.63298, that's going to bring us to 39.27 degrees. So our final answer, in order to get out of that gigantic glass prism thingy, the angle is trying to go away, since air is a faster medium with light, meaning it's going to go this way. The angle is 39.27 degrees. That is going to be the angle of which the light is coming out of the prism. And yeah, this is probably the most complicated math video we ever made in this season. I hope this video has helped you understand triangle prism problems. This one includes a lot of logical thinking. If you were confused, try to replay this video, but also take notes on it and try to logical reasoning why this works and why we made up those numbers that might seem that they just appeared out of nowhere. Thank you for watching Tao Penny Alliance Math Industry. Like and subscribe!